Before a plane even thinks about leaving the gate, there's this incredibly important invisible calculation that has to happen. It's a balancing act that's pretty much the foundation of flight safety. So today, we're going to pull back that curtain and look at the hidden world of aircraft weight and balance.
And it really all boils down to a pretty simple question. What in the world does a playground seesaw have to do with a complex airplane? Well, believe it or not, almost everything. The exact same physics that you learned as a kid on the seesaw is what pilots use to keep their planes stable and safe up in the sky.
And look, this isn't just some fun little physics puzzle. The Federal Aviation Administration, the FAA, they put it about as bluntly as you can. This is not a suggestion, it's not a guideline, it is a non-negotiable, absolutely critical part of flight safety. If you get it wrong, the consequences are, well, they're catastrophic.
All right, so let's actually dig into this whole seesaw in the sky thing. To really get how pilots manage it, we need to wrap our heads around three key ideas, three terms that are the bedrock of all their calculations.
Okay, so first up is the center of gravity, or just CG for short. Just picture this. What if you could balance an entire airplane perfectly on the tip of your finger? That one single spot, that perfect balance point, that's the center of gravity. And it's the pilot's job to make sure that point is exactly where it's supposed to be.
Next up, we've got the arm. Now, if we go back to our seesaw, the arm is just where you're sitting, right? It's how far you are from that middle pivot point. On an airplane, it's pretty much the same thing. It's the distance from a fixed point, they call it the datum, to any single item on board, whether that's a passenger, a suitcase, or even the fuel in the wings. And that brings us to moment. A moment is basically the turning force that a weight creates because of its distance. Think about it. A really heavy person sitting close to the middle of the seesaw can be perfectly balanced by a much lighter person sitting way out on the end. That leverage, that turning power that each of them has, that's the moment.
And it all boils down to this one super simple formula that governs everything. Weight times arm equals moment. This little equation is the absolute key to every single weight and balance calculation a pilot ever does.
Okay, so we've got the physics down. But what happens when things go wrong? When that delicate balance gets, well, unbalanced? See, getting this formula wrong isn't just a math error. It has serious, real-world consequences for how that plane performs and, ultimately, how safe it is.
First off, just being too heavy, period, is a huge problem. An overloaded plane needs to go faster just to get off the ground, which means it needs more runway. Once it's in the air, it's going to climb slower, it can't fly as high or as far, it's harder to maneuver, and it will stall at a higher speed. I mean, literally every single safety margin gets smaller and smaller.
But here's the thing. It's not just about the total weight. Where you put that weight is absolutely critical. If the plane is too nose-heavy, the pilot might literally not be able to pull the nose up to take off. On the flip side, if it's tail-heavy, the plane can become incredibly unstable, almost uncontrollable. Both are extremely dangerous situations.
And weight can sneak up on you from some surprising places. Take fuel, for example. We don't really think of it as being that heavy, right? But aviation gasoline weighs a solid 6 pounds for every single gallon. That means just 30 gallons of fuel weighs more than your average person. That's a huge variable pilots are constantly managing.
So with all this on the line, how do pilots actually solve this puzzle before every single flight? Well, they're not just guessing, that's for sure. They use a really precise set of tools, all provided by the aircraft manufacturer, to make sure they are safely within the limits. Let's walk through it.
All right, step one is basically an inventory of everything. Pilots use these specific charts to find the weight and then calculate that corresponding moment for every item going on the plane. And I mean everything, from the empty plane itself to each person, every single bag, and every last gallon of fuel.
Okay, so once they've got their grand totals, total weight and total moment, they do the final critical check. They take those two numbers and plot them as a single point on a special chart called the center of gravity envelope. If that point lands inside the specific safe zone defined by the manufacturer, the flight is legal and safe. If it falls even a tiny bit outside that box, the flight is a no-go, period. Something has to change. You see, this whole process really drives home what the pilot's ultimate responsibility is all about. It's not just about knowing how to fly the plane. It's about making sure the plane is even in a condition to be flown safely from the very beginning. Every single pound, every single inch, it all matters.
And here's something that honestly blows a lot of people's minds.
On many aircraft, you physically cannot have it all. You can't fill every seat, pack every corner of the baggage compartment, and top off the fuel tanks. Doing all three will often push the aircraft right over its maximum legal weight. So pilots are constantly making these critical trade-offs.
And let's be absolutely crystal clear here. Flying overweight isn't just about making the plane feel a little sluggish. The FAA warns that it can compromise the actual structural integrity of the aircraft. These limits aren't suggestions. They are the absolute laws of physics and engineering.
So really, the next time you settle into your seat on a flight, just take a second to think about all that invisible work that happened before you ever stepped on board. The physics behind it all doesn't change. It's unforgiving. The only real variable is the diligence of the person doing the math. And it kind of makes you wonder, is there a more critical calculation in all of travel?